But when it came to the base of the tree, which represented the origin of the first life, the first living cell, Darwin had very little to say. In fact, in The Origin of Species, he didn't even address the question of how life might have originated from non-living matter.
The only glimpses we have of Darwin's opinions on the subject appear in a letter he wrote to a colleague named Joseph Hooker.
Regarding the first production of a living organism, if, and oh what a big if, we could conceive in some warm little pond with all sorts of ammonia and phosphoric salts, light, heat and electricity present, that a protein compound was chemically formed, ready to undergo still more complex changes, at the present such matter would be instantly devoured. But this may not have been the case before living creatures were formed.
During the final years of his life, Darwin did little to develop his idea that a primitive cell might have emerged from simple chemicals in the primordial waters of the early Earth. But later in the 1920s and 30s, a Russian scientist named Alexander Oparin formulated a detailed theory about how this could have happened. It was called chemical evolution.
Oparin thought that he could explain the origin of the first life using Darwinian principles. He envisioned simple chemicals combining and recombining to form larger molecules, and then these larger molecules organizing themselves with the help of chance variations and natural selection into the first primitive living cell.
Over the next 3 decades, many scientists worked to develop and refine these ideas as they pondered the questions both Oparin and Darwin had raised. How could life have evolved from simple chemicals?
Since the 1950s, many scientists have felt that they could simulate chemical evolution, the kind that might have happened on the early Earth. And what they're trying to do is to take simple chemicals and put them together to form amino acids.
These amino acids are actually chemical compounds. 20 different types of amino acids are common in living organisms. They comprise about half the dry weight of every cell. Amino acids are the building blocks of larger molecules called proteins. And proteins are the primary components of every cell that has ever existed on the Earth.
Proteins have a wide range of function in the cell, everything from structural requirements in terms of scaffolding of the cell, the cytoskeleton, to enzymes.
Proteins do all the day-to-day jobs inside of the cell, making energy, moving things around, cleaning up the cell. And the earliest cells had to have those same proteins because they needed those same jobs done. So the proteins in the earliest cell and the proteins today were of the same type of complexity.
Scientists realize that the complex structure of protein molecules are keys to understanding how life on Earth began.
By the 1960s, scientists had determined that even simple cells are made of thousands of different types of proteins. And the function of these molecules derives from their highly complex three-dimensional shapes. The irregular shape